Hello, everyone, and welcome to this introduction to the online training on Biosolid and Sludge management on Sanihub. This training is an initiative as part of Octopus, the operational collaborative tool of ongoing practices in urgent sanitation that was implemented by Solidarité International. My name is Stefanie Abulasim-Thieme, and I'm from UPM Umwelt-Projekt-Management, who prepared the contents for these trainings. In this video, I'm excited to give you an initial overview of what you can look forward to in the Octopus trainings, particularly the training focused on Biosolid and Sludge management. These trainings are designed based on a comprehensive needs assessment and aim to enhance understanding of critical aspects of fecal sludge management, especially in crisis situations. While they don't substitute for the expertise of professionals in planning and design, they ensure that all stakeholders possess fundamental knowledge in this crucial field. I encourage you to check out the Sanihub website, where you can find the 3 major trainings on biogas sanitation, effluent management, and sludge and biosolid management. Each training consists of several modules and lessons. These are open access, self-paced trainings that enable a flexible navigation and progress tracking. If you complete an entire training, you will receive a certificate of completion. But as you're liking, you can also jump into any topic that you would prefer to learn more about. And in this introduction session, I want to talk more about the training on sludge and biosolid management. The training has the objective to provide you with an overview of appropriate sludge and biosolids management practices and provide you with practical solutions that ensure safe and responsible handling up until safe and disposal or reuse of sludge or biosolids. So the key topics that will be covered are different pre-treatment and treatment options. Then we will dive into the reuse of sludge with a focus on agricultural purposes. We will talk about burial and disposal of sludge, as well as burning of sludge. While these trainings will overall take a few hours, this introduction session wants to introduce you to what is sludge and why its management is important, what are the different sludge management options, what are common biosolid use and disposal techniques that you will learn in more detail in the training itself. And last but not least, I want to talk a little bit about how sustainable sludge burning actually is. So let's start with what is the difference between sludge and biosolids. As made a picture already visualized to a certain extent, there are differences regarding the treatment level, pathogen content, stabilization, and usability of sludge and biosolids. Sludge can be described as a mixture of solids and liquids, raw or partially digested, also meaning untreated or only partially treated, and usually has a higher level of pathogens. In comparison, biosolids are semi-solid organic materials, are partially or fully stabilized and sanitized, and meet after treatment certain standards, guidelines, or requirements. When we look at the sanitation value chain, we can explain the differences in more detail. So we start with the user interface. In our toilet, we dispose of feces, urine, toilet paper, wash and flush water. All this combined results in black water that then flows in the non-sewage systems into a containment that provides a collection place, a storage, or also realizes a first treatment. Here in this particular slide, we see a standard septic tank. In a septic tank now, the black water will separate into the more liquid phase that will continue into the next chamber and leave a so-called effluent. while the solid particles will settle at the bottom of the tank, and the accumulation of these particles can be described as sludge. Now, this septic tank or first step that we just saw could also be described as a thickening stage. Now, the sludge that is separated in the stage will continue into a stabilization stage that can be aerobic, anaerobic, or chemical process. After that, the sludge can be considered partially treated. Following the stabilization is the conditioning that is usually chemical, where you mix in, for example, hydrated lime into the sludge. The then partially treated sludge will undergo dewatering, either mechanical or drying. And finally, this will result in so-called biosolids. That means at the end of the treatment, you have biosolids, treated sludge that has undergone processing to meet specific quality standards. Now, why is sludge management important? I think it's obvious, especially when it comes to pathogens, that sludge management is essential to guarantee environmental health as well as public health by avoiding that untreated or only partially treated sludge ends up in our soil or in our water sources. And last but not least, sludge can be the source of or can be considered a resource. So sludge management is important to enable resource recovery. But what to decide or how to decide what type of sludge management is suitable? Now here we have some kind of ranking. When we look at what are the possible treatment objectives, then the most preferred should always be safe reuse, meaning the application of treated sludge or biosolids as a fertilizer and soil amendment in agriculture or land reclamation or landscaping, while ensuring the environmental protection and public health. Now, if we don't have the conditions for safe reuse in place, an alternative would be the safe burial of the sludge. That means controlled containment of treated sludge to prevent the environmental contamination and protect the public health during this disposal. And if a safe burial is again not possible, only then we should consider safe burning. This means the controlled combustion of the treated sludge to reduce the volume and destroy pathogens and minimize the environmental impact. Next, I want to talk about the conditions for safe reuse, safe burial, or safe burning. Let's look at reuse. Ideally, for safe reuse means that you enable this reuse on site of your treatment plant. So you have the entire setup for the processing of the sludge and biosolids right at your treatment plant without transportation in between. This requires a sufficient amount of space for this controlled reuse. And if you don't have the space, then it may be necessary to consider one of the alternatives. Now, the treatment design, the steps that your sludge has to undergo for reuse, must focus especially on the helmet egg reduction and allow the necessary drying. The reuse is limited to treated sludge that is conform with national legislation or standards. That means at the end, you reach the title of biosolids, like you reach the conditions of biosolids. And last but not least, of course, you need all the information, means, tools, materials for this sustainable sludge treatment for the entire duration of the implementation. Now, if these conditions for reuse cannot be guaranteed, then it may be more suitable to aim for safe burial. But also there, environmental conditions are very important. You need to look at the groundwater level. So if you have the space for the safe burial of your sludge, you still need to ensure that the bottom of the pit or trench where you bury your sludge in is at least 1.5 meters deeper. Also, you need to pay close attention to the distance to water sources. The closest water source should be more than 30 meters away from the burying point. Also, for safety reasons for animals as well as humans, you need to restrict the access and ideally fence the burying site to avoid any kind of contact for animals and humans. And again, all the materials or tool or means or information that are necessary for the safe burial need to be available for the entire time of duration. Now, if you cannot guarantee these conditions because you are in an area with high groundwater levels or where it is especially wet and rainy, then maybe the safe burning of sludge comes in more handy. Here, it is especially important that the sludge before burning is extensively dried. Ideally, you have sludge that is dried, that has a dry matter higher than 35%. Then when it comes to burning, we need to pay close attention to the generated gases, because these are usually harmful emissions that need to be prevented. And there needs to be a sustainable concept in place to manage produced ash and other byproducts. But here in a bit more detail later in this session. Until then, or first, let's look at what are common biosolid use and disposal techniques. So first, and I think the most famous one, is the composting or co-composting. Co-composting means the sludge would be mixed, for example, with other organics, such as kitchen waste. Composting is considered a controlled aerobic decomposition process of sludge and biosolids mixed with other organic solid waste. And this procedure yields a stable, humus-like and odor-free end product known as compost that can be used as a fertilizer or soil amendment. An alternative to regular composting is vermicomposting. At the center of vermicomposting are earthworms that actively feed on the sludge and biosolids. These type of earthworms are, for example, also found in cow manure that is distributed on the fields. They ingest the material and break it down through their digestive processes. The earthworms excrete castings, which are nutrient-rich granular material known as vermicast. Another very interesting treatment options is the black soldier fly larvae treatment that uses black soldier fly larvae, as shown in the picture, to break down the organic matter and fecal sludge to convert into valuable byproducts such as compost and animal feed. If you want to learn more about these very interesting treatment methods, check out the training. I want to talk now in the last few minutes about how sustainable sludge burning actually is. So what does sludge burning actually imply? First, it describes a thermochemical process at high temperatures. And there we can differentiate between incineration, gasification, and pyrolysis. Very essentially, for all these processes, you will achieve a significant reduction of sludge volume, eliminate pathogens, and have extremely low treatment or fast treatment times. And another advantage is the potential resource recovery, as you may use the ash or biochar that is being produced. But at the same time, with all these advantages, you also have certain amount of risks when it comes to sludge burning. For example, sludge often contains heavy metals or poorly degradable organic compounds and other pollutants. Burning sludge can potentially release these harmful substances into the air if not properly controlled. If the sludge contains pathogens and is not burned at sufficiently high temperatures, there's a risk of dispersing these disease-causing organisms into the environment. Also, sludge burning requires careful control of temperature, airflow, and other parameters. Improper operation can then lead to incomplete combustion, increased emissions, or also equipment damage. And last but not least, emissions from sludge incineration, if not properly treated, can contribute to air pollution and potentially impact the surrounding ecosystems. And the risk of these generated emissions is that in the first glance, you may not observe them. But at the end, you breathe it in, and what you can smell or what is being released into the environment are nitrogen oxides, volatile organic compounds, particulate matter, dioxins and furans, and greenhouse gases, including carbon dioxide, methane, and nitrous oxide. So with this in mind, it is essential for a sludge burning system to have a very good exhaust gas management. Now here in this picture, you see a very simple furnace for incineration with a chimney and filtration system that may often, when you aim for a more low-cost, simple solution, not be sufficient to really avoid or prevent emissions. In addition, is very necessary to have a reliable design for the containment and the process itself. And it is very essential to look at your sludge. You need to ensure that the moisture content is low. So the dry matter content should be at least 35%. Then you need to consider the calorific value of your sludge. Undigested sludge with high organic content has usually a higher fuel value. And what I also already kind of mentioned is that you have to keep in mind or test also for contaminants in your sludge that will also end up in your ash and biochar and impact the emission generation. So with that in mind, please check out the training and let's turn our muck into magic and cultivate a greener tomorrow. I thank you very much for your attention and invite you to explore our trainings and give you feedback under octopus@solidarite.org. Also, any type of questions, comments, and improvement suggestions are very much welcome. See you later. Thank you.